Have you ever looked up at the night sky, spotted Jupiter, and wondered, what if our own planet was that big? What if Earth suddenly swelled up to the size of the gas giant? It sounds like something out of a sci-fi movie, but let's actually explore this fascinating idea. If Earth were as massive as Jupiter, what would life, or what's left of it, be like? Let's dive in and find out. First, let's get the scale right. Jupiter is enormous. You could fit all the other planets in our solar system inside it, with room to spare. Its diameter is about 11 times that of Earth. If you scaled Earth up to that size, keeping its density the same, its mass would increase by over 1,300 times. And this is where our problems would begin. The first and most immediate effect would be gravity. With a mass 1,300 times greater, Earth's surface gravity would be about 11 times stronger than what we're used to. Think about that for a second. If you weigh 150 pounds, you'd suddenly feel like you weigh over 1,600 pounds. Just standing up would be an incredible workout. Walking would be like trying to move through thick molasses while carrying a car on your back. Your bones, which have evolved to support your weight in our current gravity, would likely shatter under the immense strain. Your heart, a muscle designed to pump blood around your body, would struggle against this incredible force. It wouldn't be able to get enough blood to your brain, and you'd pass out almost instantly. But let's imagine for a moment that humans could somehow survive this. What would our world look like? Well, for starters, everything would be flat. The intense gravity would pull everything down with such force that mountains would crumble under their own weight. Mount Everest would be flattened into a mere hill. The entire surface of the planet would become incredibly smooth. Trees, buildings, everything we've built would collapse. Nothing could stand tall against such a powerful gravitational pull. It would be a world without skyscrapers, without mountains, without even tall trees. And what about the atmosphere? A super strong gravity would hold onto our atmosphere with an iron grip. It would pull the gases in, making the air at the surface incredibly dense. The atmospheric pressure would be crushing. We'd be talking pressures far greater than what you'd experience at the bottom of the deepest ocean trenches on our current Earth. Breathing would be impossible. The sheer pressure would compress the air into a state that our lungs simply couldn't handle. The nitrogen in the air would become toxic under such pressure, a phenomenon known as nitrogen narcosis. So even if you could withstand the gravity, the air itself would be deadly. Let's think bigger. What would this supersized Earth do to our cosmic neighborhood? A planet with the mass of Jupiter, in Earth's current orbit, would wreak havoc on the solar system. First up is our lovely moon. The intense gravity of our new giant Earth would pull the moon in. Depending on its trajectory, it might get ripped apart by tidal forces, forming a spectacular ring system around our planet, much like Saturn's. Or it could spiral inward and collide with us in a cataclysmic impact that would sterilize the planet. Either way, say goodbye to moonlight strolls. The other planets wouldn't be safe either. A Jupiter-mass Earth would become the new gravitational bully of the inner solar system. It would tug on the orbits of Venus and Mars, potentially flinging them out of their stable paths. Mars could be ejected from the solar system entirely, or sent on a collision course with another planet. The asteroid belt would be completely disrupted. We'd likely see a massive increase in asteroid impacts on our giant Earth, as our gravity would act like a cosmic vacuum cleaner, pulling in any space rocks that stray too close. And what about the Sun? Our current Earth has a negligible effect on the Sun's position. But a Jupiter-mass planet in our orbit would be a different story. The Sun and our new Earth would orbit a common center of mass called a barycenter that would be located just outside the Sun's surface. This would cause the Sun to noticeably wobble as we orbit it. This wobble is actually one of the ways astronomers detect exoplanets orbiting other stars. So any alien astronomers looking at our solar system would see clear evidence of a large planet orbiting close to our star. But would our new planet even remain a rocky planet like Earth? This is where things get really interesting. With a mass over 1,300 times that of our current Earth, the immense pressure and heat at its core would trigger nuclear fusion. But not the kind of fusion that powers a star like our Sun. The pressures wouldn't be quite high enough for that. Instead, it would likely start fusing deuterium, a heavy isotope of hydrogen. This would turn our giant Earth into something called a brown dwarf, or a failed star. It would start to glow with a dim, reddish light. It wouldn't be as bright as the Sun, but it would emit its own heat and light. Our planet would become a secondary, smaller star in our own solar system. We'd have a binary system, with our tiny sun and our new brown dwarf Earth orbiting each other. Nights would no longer be dark. Instead, they'd be illuminated by the faint, eerie glow of our own planet. The concept of day and night would completely change. This internal heat source would make the surface of our planet incredibly hot. Any water would have boiled away long ago. The surface would likely be a molten, hellish landscape. So not only would the gravity crush you and the atmosphere poison you, but the ground itself would be a sea of lava. Not exactly a vacation destination. Let's recap the journey from our familiar blue marble to this monstrous brown dwarf. First, gravity increases 11-fold, crushing every structure, natural and man-made. Life as we know it is instantly extinguished. The atmosphere becomes a thick, toxic soup with unbearable pressure. Our moon is either shattered into a ring or crashes into us. The orbits of our neighboring planets are thrown into chaos. And finally, the immense pressure at the core ignites nuclear fusion, turning our planet into a smoldering, self-luminous failed star. It's a pretty grim picture, isn't it? It really makes you appreciate the delicate balance of factors that make life on our actual Earth possible. The size, the mass, the distance from the sun, it's all a cosmic balancing act. Our planet is in the Goldilocks zone, not just in terms of temperature, but in so many other ways. It's a powerful reminder of how special and fragile our home is. Being the size of Jupiter might sound cool in theory, but in reality, it would be the end of everything we know and love. We're lucky to be on the small, rocky, life-sustaining planet that we call home. What do you think? What other cosmic what-ifs would you like us to explore? Let us know down in the comments. Thanks for watching, and if you enjoyed this journey into the impossible, don't forget to like this video and subscribe for more mind-bending science. See you next time.